Hello, this is Geometry Lesson 4-6, Congruence in Overlapping Triangles. In this lesson, we'll be able to use triangle congruence to solve problems with overlapping triangles. So let's look at exploring reason. Look at this painting. How many triangles can you find? So initially, you can quickly count the triangles and say, oh, there are a total of 15 triangles. Okay? Are there any triangles that's made of smaller triangles? Do we see any other triangles that are bigger? Right? So how many triangles do you think you see total? Are there any triangles that's overlapping? Okay. And how can you avoid counting some triangles twice? Maybe you want to make a chart, or you want to list triangles that you already counted, but how are you going to name all these triangles? You can draw over it, right? So the total triangles should be, counting all the overlapping triangles, you should be able to find 30 triangles total. Okay, 15 plus 16, 17, 17, and then 18, and so on, 19, right? 20, and count all the overlapping triangles. You should be able to find 30 triangles. If you couldn't find 30 triangles, go ahead and count again. So what are some strategies that you could use to count the triangles? How well would your strategy work? You can number the triangles, okay? And then you can list the triangles. And okay, also you can make a chart of triangles that you counted. Sure. Okay, so if you count the triangles that doesn't have any overlap, that's 15. And then you can count triangles that has 2 triangles overlapping, and then 3 triangles, 4 triangles, and then you can keep track of how many triangles you have, right? So in this lesson, we're going to think about the theorems that could be used to prove that 2 overlapping triangles are congruent. Okay, so far we've looked at all the triangles that weren't overlapping. What if they're overlapping? Let's look at example 1. Identify corresponding parts in triangles. Figure ABCD is a rectangle with diagonals AC and BD. Why is it important to identify corresponding parts of overlapping triangles? Okay, why is it important? So we have diagonals and we have opposite sides that are congruent. We have right angles that are congruent. We can see that 2 segments AB and DC have the same length. BC and CB is a common side in both triangles. 2 angles ABC and DCB are right angles. So using the parts, we can use, you can determine if the triangles are congruent or not using the corresponding theorems, right? So if you identify the information, then you should be able to prove if the triangles are congruent or not. So it is important to identify corresponding parts so that you know which is corresponding to which. And then you should be able to use the theorems to prove their congruency. Let's look at try number 1. What are the corresponding sides and angles in FAHJ and KHG? One hint is that you look at the orders of the points. F should be congruent corresponding to K, H to H, J to G. Okay, and so lines is the same order. So FH should correspond to KH. Okay, the order does matter because we're talking about corresponding parts. Okay, so without looking at the diagram, you can just figure out that angle F and K should be congruent, H and A should be congruent, J and G should be congruent, but the angles must be specified, right? So FHJ in this triangle, we have angle FHJ and angle HJF and angle JFH. Okay, that should be congruent to the corresponding angles for KHG. Okay, your order must be the same. So FHJ should correspond to KHG. HJF should correspond to HGK. JFH should correspond to GKH. Okay, and then the sides are the same way. FH should be congruent to KH. HJ should be congruent to HG. And JF should be congruent to GK. Okay. So example 2, use common parts of triangles. Is angles EGD and EFH congruent? EGD, this one, and EFH, this one, are they congruent? First, identify where did the two triangles overlap, right? And what part of that triangle lies on the triangles you need to show are congruent. Okay, EFG is a triangle that is overlapped, right? Since these sides are congruent, DEH is isosceles, the big triangle is isosceles triangle, and so D and H should be congruent by the property of isosceles triangles, right? We learned that last lesson, last topic, right? So since the sides are congruent, we can say that DG is congruent to HF by the segment addition postulate. And because that, we can prove that the true triangles, overlapping triangles, are congruent by SAS. By CPCTC, your angles are congruent. Okay. So let's look at try question number 2. Are lines VW and VY congruent? Come back when you're ready. Okay, since WVX, YZX, they're congruent. And XVZ and XZV, they're congruent. So these two angles are congruent, right? So we can say, because these angles are congruent, VZ and VZ is congruent to itself, we can say that, also WZV, and using the angles, right? These two angles are congruent, and then these two angles are congruent. We're looking at these two triangles, right? And if these two sides are congruent because of reflexive property, and these two sides are congruent because by the angle addition postulate, and then these two angles are congruent by given information, then we can use angle side angle to prove the triangles are congruent, right? The overlapping triangles are congruent. All right, so let's state what we have. WVZ congruent to YZV. VZ congruent to VZ by reflexive property. And this is angle addition postulate. And then WZV congruent to YVZ by given information. We can say that two triangles VWZ and ZYV are congruent by ASA. And so we can say that VW is congruent to ZY by CPCTC. Okay? Let's look at example 3. Prove that two triangles are congruent. Write a proof to show that triangle BFE is congruent to CEF. So we're looking at these two triangles, right? So if it helps you, you can separate them and see which parts are the same. FE is the same, so they're going to be congruent by reflexive property. Okay, and do we know any other information? We're given the other sides outside the triangle so are congruent, other parts over here, and the angles here. So we might have to prove other triangles are congruent first, and then use CPCTC to prove to get more information, right? So given that AF is congruent to DE and FE is congruent to itself, AE is congruent to DF. Does that make sense? By the segment addition postulate. And now we have this and this congruent to each other, we're looking at these two bigger triangles. Since AB and DC are congruent and A and D are congruent, we can use SAS to prove the bigger triangles are congruent. And by using CPCTC, BE is congruent to CE. And using that, SAS, we have BFE congruent to CEF. Okay. So let's look at try question number 3. Let's write a proof to show that triangle SRV is congruent to TUW. Come back when you're ready. Okay, I'm going to start with the given information. SR congruent to TU, given, okay, and SRW and TUV are right angles, right triangles, so definition of right angles by given information. We're going to say SWT is congruent to angle TVS and angle STW is congruent to, let me write that in another column. VST. And wait, these are given. These are all given. Okay. And then we're going to prove the triangles are congruent. So since these two are congruent, we're going to say that ST is congruent to itself by reflexive property. Okay. And then we can say that the triangles SWT and TVS are congruent by AAS, triangle congruence criterion. So by CVCTC, we know that SV is congruent to TW. And also, because this given information, these two given information, we can say that triangles SRV is congruent to TUW by HL theorem. Okay, so we're done. Triangles SRV and TUW are congruent. Example 4, separate overlapping triangles. A city runs 3 triangular bus routes to various attractions. How can you draw a separate triangle for each route? Are any of the routes the same length? Okay, we have some destinations and we see some triangles over here and some distances. Are any of the routes the same length? So we got routes by triangles. We got green route, red route, and purple routes. Are any of them the same length? Okay, we got bus stops for the different routes. You can use a map and the list of locations for each route to help you draw the triangles. You can add the length and angle information to your diagrams. And you can notice that by HL, the triangles representing the green route and the red route are congruent because they're right triangles and they have 2 same sides. Therefore, the green route and the red route are the same length. So even without calculating all the distances, you can figure out that the 2 triangles are congruent, and then you can say the routes are going to be the same. Let's look at try number 4. A new route will stop at the History Museum, Water Park, Zoo, Science Museum, and Theater. Draw a triangle to represent the new route. Include any length or angle information that's given in the diagram. So we're gonna stop at the History Museum, which is here, okay? And then Water Park and Zoo, Science Museum. Where is the Science Museum? Okay, and theater. So our new triangle, let's use a different color, maybe sky blue. Okay, so this is our new triangle. Okay. Draw a triangle. We did draw a triangle. To represent the new route, include any length or angle information that's given in the diagram. So we can add these 2 lengths and say, oh, this side is going to be 3.5. And this is going to be 2. And then that's a hypotenuse. And then that's just going to be a right triangle. Let's figure out the hypotenuse as well. That's going to be 4.4, right? So we're gonna draw that as an answer. Okay. We don't really know if it's a right triangle. So we're just gonna put all the sides. 4.4 kilometers, 3.5 kilometers, 2.0 kilometers. Okay, that's it. So let's summarize our lesson. Congruence in overlapping triangles. Are all congruence criteria can be applied to overlapping triangles? Okay, so if your triangles overlap, it doesn't mean they're a different figure, they're still triangles. And you can use side, 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 angle, angle, side, the HL theorem to prove the triangles are congruent. And by looking at the overlapping triangles in this lesson, what observations have you made about the different ways triangles can overlap? You might have noticed that overlapping triangles can share a side, an angle, a part of a side, or a part of an angle. So using those information, you're going to identify corresponding angles and sides and use the theorem, congruency theorem, to prove the triangles are congruent. All right, that was our last lesson for the topic. So congratulations for finishing the topic. We'll see you in the next topic. Bye.